Hey YouTube, this is Sean with Griffin RC Planes. I hope everybody had a good week. Maybe you guys can get out and go fly this weekend. Here in Middle Tennessee, we've had spring-like temperatures. Been unreal yesterday and today. And tomorrow, Saturday, is supposed to be not as hot, but still mid-70s and sunny. So my plan is to get out and go fly, and I hope you guys get to do the same. So I was thinking about a video for this evening, and like I mentioned, I'm putting out a bunch of different stuff to see what you guys are watching. Well, we recently just got those servos from Radio Shack, and we're doing the Tower Hobbies Uproar version 2 build, and right now we're in the stage where we had to make these adapter plates in order to put a smaller servo in the pre-existing holes for the wings where the servos go in the wing for the ailerons. And we just made a little plywood plate or a board, a flat piece of wood, just to adapt the hole size down. Well, then I got these Radio Shack servos from one of you guys, which I think are just really cool. And I said, we could do away with this adapter plate and just put these servos in. Well, then I got to thinking, I wonder how much how many amp draw, what's the voltage range and all that. And it said a few bits and pieces of that information on the package, but it didn't say amp draw. And then I got to thinking, older servos, analog, a long time ago, those things ate up battery packs like crazy. So, hey, let's put some servos through a servo tester, through this one, the multimeter, and let's see what kind of amp draw each servo is testing. I got a handful of servos. None of this will be, accurate. I don't have my buddy at NASA helping us out, to get all these calculations right. But we can just see that this one is using more than that one and less than this one, and vice versa. So let me plug up some servos and get some wires out in the battery, and let's see what happens, huh? All right there, guys and gals. As I just talked about, we're going to hook some servos up through a multimeter and see what kind of amp draw each servo is using. Now, none of these servos are equal comparisons. This current setup is not a precise setup. This is just for us to see that some servos use more than others, some use less, just for pure entertainment. Okay, in order to be precise about this is way over my head, but I know that the type of wire, how the wires configure, the voltage on the battery, a lot of stuff can go into this, but this is just to see what kind of amp draw goes through each servo. If you have a lot of amps, it could eat up a battery pack really quick. So here's the setup. Is to start out, I got a battery and a cheap meter here showing that we got 5.4 volts. This is a servo tester. Instead of plugging the battery directly into it, we're plugging the battery into a lead that the negative is going straight into the servo tester. The positive is going into this alligator clip here, coming onto this lead, going into the left side of the multimeter, coming out of the multimeter, going into these alligator clips, then into the servo tester. Okay, so right now there's zero load on this setup. That's why the meter is reading all zeros. All right, I'm going to put the servo tester in the center position. Now don't forget, the reason that I wanted to do this is to check out these Radio Shack servos right here. Well, this e-flite 23 gram digital servo is what I'm putting in the Tower Hobbies Uproar. And we had to build an adapter plate because the size servo that was supposed to be used by the manufacturer, they already cut a hole out in the wing big enough for a standard size servo, like the Radio Shack one. So then I thought, hey, I got these servos now. Maybe we'll do away with the adapter plate and put these in. Well, let's see what kind of juice they're drawing. So the first servo we're going to plug into is the one that we're using, the digital 23 gram. All right, it's in the center position. The next click is back and forth, back and forth. Then the first setting up here is manual. Okay, we're in the center position. Now let's say you're flying and you're holding your stick to one position and the wind is pushing back on the control surface. Look, it's using 1/10 of an amp, just the wind holding on it. Then we can put it on the back and forth motion and we can crank it to the max, and you can see it's pulling 4/10, 3/10 of an amp. All right, so we got 3 or 4/10 of an amp with that digital one. Here's our Radio Shack servo. We got the servo tester in center. All right, no load at all, it's just sitting here. Now it's the wind. 4/10, 5/10 of an amp just from the wind. We'll put it on back and forth and crank it up, and there it is, 0.7, 0.8, 0.9, almost 1 amp on the analog Radio Shack. This is another e-flite Spektrum digital servo, a bigger one. This one's in bad shape. The gears are bad. It's rough. So let's see what it might use a lot of juice because it doesn't turn smoothly. Put it on manual here and you can just hear it. It's bad. Back and forth to the max. There's almost 11 at one point. And that's a digital servo. Well, that was a lot of fun. I'm going to do my homework to figure out how to be more precise with this. And that way we can run through a lot of servos. One of the ones I didn't test, but I did on the, when I was making sure this worked before I filmed it, was one of them real cheap blue 9-gram servos. You know the ones you see advertised. They're 10 for $4 or something. And that drew 5 times as much as any of them. It was bizarre. I've got a DC power supply that's adjustable for any voltage you want, and it'll hold that volt without dipping down like this battery pack did. When I did full blast on the setting where it went back and forth, it probably went from 5.5 volts down to 2. I mean, there's just no telling what it was taking. But I can use this power supply and hold the voltage firm. Here, I'll show it to you right quick. Okay, BK Precision DC power supply. Right now it's set at 5.7 volts. The knob on the right increases the coarse voltage. All right, and then the knob on the left fine tunes it, so you can go 11.3, 0.4. Then you can adjust the current. How many milliamps of or the C rating. How strong is the 11.3 volts? Plus, it's got this voltmeter built in, and I don't know exactly what those buttons are. And then I believe, and I don't know, don't quote me out. Hey, you guys tell me, what is the middle thumb screw here? I know the positive and negative for sure. I've got to go into this XT90 lead, but I don't know what that is. It must be ground. I probably just answered my own question. Now you guys are so smart. You taught me right through the dang camera. But BK Precision DC power supply 1635A, and you can adjust all the voltage, fine tune and stuff. It's something. I actually found that dumpster diving years ago. And I didn't even know what it was, but it was heavy, and it had an extension, a cord on it, and some knobs, and it looked interesting to me. That thing's worth several $100 right now, and who knows how old it is, but That's really good to use instead of a battery pack. You know, if you're doing something and you get your speed control and your motor hooked up, instead of getting the battery out, or let's say you're building a plane and you're trying to decide if you're going to use a 3S an 11.1 volt, or a 4S a 14.8, or a 6S 22.2. You know, you're trying to figure out what battery pack you're going to use. You can take that DC power supply, adjustable power supply. Yeah, spit it out, Sean, spit it out, and dial in whatever you want. And that's the same thing I can do with this servo testers. You know, some of them say 4.8 to 6 volts, and then the high voltage servos go to 8.4 volts, I believe. We can set it and it'll stay there. So yeah, I'll do some homework and figure out how to get everything set up just right, and we'll run through that whole test again. Well, alright guys, hey, I'll have a few more videos coming this weekend. I want to run through the FMS Avanti right here. Yes, for those of you that don't know, once we hit 1,000 subscribers, I'm going to do a drawing that is fair for everybody, and I'll figure out exactly how to do that. You know, it won't be if you're subscribed, you're entered, because somebody subscribed on accident, somebody's subscribed and, you know, hasn't been on the channel in a couple months, and, you know, it's going to be for the people that watch. So I'll talk to some other people. I'll figure out with YouTube. You know, there's a whole YouTube studio how I can get all kinds of tools, the random name picker for the prizes, and I'll figure out how to make it all fair. You know, it might be something like everybody that wants to be entered, leave a comment in the next 2 weeks or something. Now that lets me know that you watch and you're still in. And who knows, 1,000 could get narrowed down to, you know, 50. No telling. Now I've got 10 family members that are automatically, you know, excluded. So, you know, a lot of things could happen like that. And then at 100 subscribers, I'm going to do something for you. And I'm going to do the same thing to where it's going to be people that are currently watching and paying attention. And, you know, my 10 family members already takes that to a 1 in 90 chance for you. And I'll figure out exactly how to make it fair. We're at like 60 right now. If I keep up what I'm doing and you guys keep up what you're doing, we'll have 100 hit this time next week. So I'm going to do something cool. It's going to be something from me to you out of my personal collection. We'll figure out, you know, what you're working on, what you're dealing with, and you know, I might have that little gem you're looking for, you know, or if I don't, we'll do a gift certificate to Tower Hobbies or something. Be my appreciation. But all right, guys, hey, until next time, you'll see me here. All right.